In this lesson, we'll be discussing polar coordinates in the polar coordinate system. So in polar coordinate system, the polar axis is the positive x-axis, which is 0 degrees. The pole is a point 0 at the origin. Each point P in the plane is assigned to the polar coordinates r, theta. R is the directed distance from 0 to a point P. Theta is the directed angle with the initial side on the polar axis and the terminal side on the line OP. If r is less than 0, then P is on the terminal side of theta. If r is greater than 0, sorry. If r is less than 0, then P is on the terminal side of theta plus pi, or theta plus 180 degrees. This will make more sense in the next couple examples. So let's look at some examples. So we have r theta being 3, 2 pi over 3. So this is what our polar grids are going to look like. They're going to look like circles. Here we have the polar axis. This is the positive x. And then we have a couple other axes labeled. We have the y-axis, and then these are going to be 45 degree markers. So we want to graph 2 pi over 3. So you're going to go out to 3, so 1, 2, 3, and then we got to go up to 2 pi over 3. So 2 pi over 3 is right along here. So that's pi over 3, and then 2 pi over 3, just like in our unit circle. So we go out to 3, 1, 2, 3, and since it's positive, we follow this right along, and we're going to plot this point here. Okay, so that is the point 2 pi over 3. Now the second one, -2, 60 degrees. So this one, our r is negative, so we're going to go on the theta plus pi axis. So we go over -2, and 60 degrees lies right here. But since we went to -2, we're going to go the other direction, and our point is going to lie here. So go 1, 2, and down. So when you go negative, you start counting your degrees in the opposite direction. Okay? So now we go over to 5 pi over 3. We're going to go over -4, 1, 2, 3, 4. And we want to go to 5 pi over 4. So we would normally count 5 pi over 4 as 1, 2, 3, 4, 5 pi over 4. But starting here, you're going to keep counting in that same circle. So it's going to be -4, 1, 2, 3, 4, 5 pi over 4. So whereas we landed here before, we're going to be on that pi plus theta axis. Okay? And our last example, -1, 315 degrees. So 315 degrees, if we start from this axis over here, you go 315 degrees, you're going to be down here somewhere. But since we're starting at -1, 315 degrees, we count 45, 90, 220, go all the way around, and we have 315 degrees here. Another quick way is look at 360 degrees minus 315 degrees. That's 45 degrees, so you know you'll be 45 degrees short of where you started. Okay? So if you're starting with a positive r value, you start on that positive axis, and you count your angle like normal. If you start with a negative r value, you start on the negative axis and you count your angle same counterclockwise direction, but from where you start. Okay? So now we want to look at finding all of the polar coordinates of a point, because just like in our unit circle, you can keep going around and end up at the same place. So the following name the same point. We have r, theta, we have r theta plus 2 pi k, and we have -r theta plus pi plus 2 pi k. Note that since this is times k, it is not the same as theta plus 3 pi k. Okay, so to find the other polar coordinates for -2, 3 pi over 4. So first we have -2, 3 pi over 4, we can add plus 2 pi. Okay? And that'll give us negative 2, 11 pi over 4. Now you can take any multiple of 2 pi and add it, and you'll end up with a polar coordinate that is the same point. You can also do negative r, so negative negative 2 is 2. Then you can do 3 pi over 4 plus pi, and you'll get 2, 7 pi over 4. So these are the same point, and again you can add any multiple of 2 pi to these angles here and you'll end up at the same point. Alright? So now let's look at some coordinate conversions. You can convert from polar to rectangular by using the following. X equals r cosine theta and y equals r sine theta. R, again, is your radius or that first coordinate point, and then theta is the angle. You can convert from rectangular to polar using r squared equals x squared plus y squared. You have to remember that r is positive or negative, and tangent theta equals y over x. Okay? So we want to convert to rectangular or polar. So this first one is going from polar to rectangular. Okay? So we know going from polar to rectangular we can use the following. X is going to be r cosine theta, y is r sine theta. So x equals r cosine 5 pi over 6. So x equals negative 2.598. Y equals r, which is our 3, sine of 5 pi over 6. So y equals 1.5. So our new coordinate is negative 2.598, 1.5. So these are our rectangular coordinates for the polar point 3, 5 pi over 6. So the next one, we're going to go from rectangular to polar. See, because there's no angle, no degree sign here, so we're going to see it's rectangular to polar. So now we have r squared equals our x squared plus our y squared. So r equals plus or minus 3. So we have 0, that goes away. And now we need to find the angle. The angle is tangent inverse of y over x, 0 over negative 3, which equals 0. Tangent inverse of 0 is 0. So our new polar points are negative 3, 0, and 3, pi. So these are our polar points for the rectangular coordinates negative 3, 0. Note that this negative 3, 0 are the same. It's because there is no angle involved, so the same 0 degree angle is going to be same as moving up 0 on the y-axis. Alright, let's look at another example. So this one again is going to be rectangular to polar. So we'll have our r squared equals negative 1 squared plus negative 1 squared. We took our x squared and our y squared. So we have our r squared equals 2. So r equals plus or minus the square root of 2. Now we need to find our angle. So the tangent inverse of negative 1 over negative 1 equals pi over 4, because tangent is equal to 1 at pi over 4. So now we can make our polar coordinates. We have this negative square root of 2 pi over 4, and we have the square root of 2 5 pi over 4. The reason it goes in this order is you have to keep in mind where your original point was. So the original point, negative 1, is in the 4th quadrant. So when you graph your polar coordinates, you want them to be in that fourth quadrant part of the circle. So we had to go over to -2 and then down pi over 4. And that'll get us in that fourth quadrant. Or you can go to square root of 2, which is moving right, then going all the way around to 5 pi over 4, which again puts us in that third quadrant. Last one is going to be 200 degrees is polar to rectangular. So we have x equals 2 cosine of 200 degrees. So x equals -1.879. Y is 2 sine of 200 degrees. So y equals -0.684. So our new rectangular point is -1.879, -0.684. And that will match the quadrant that it is in currently. Okay? So make sure, especially when you're going from rectangular to polar, when you're using those positives and negatives, that you're making sure that the point you're creating in polar matches the quadrant that you were in for rectangular. And the last thing we're going to talk about today is equation conversion. So we can use the same same coordinate conversion equations to convert from polar form to rectangular form and vice versa. So we can use these same things to convert our equations. So let's look at our first equation. We want to convert this to polar form. So remember that x was our cosine theta and y was our sine theta. So I'm going to distribute these out first. So I'm going to have x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals 13. So I can take my x squared plus y squared and group it together. And then I'll be left with minus 6x minus 4y. 9 plus 4 is 13, so I can move that to the other side, and that equals 0. So now I can plug in x is our cosine theta, and then y is our sine theta. But we know x squared plus y squared equals r squared. So 6 times r cosine theta minus 4r sine theta equals 0. So now, going from here, I can factor out an r. So I have r times r minus 6 cosine theta minus 4 sine theta equals 0. So here I know that r equals 0 or r minus 6 cosine theta minus 4 sine theta equals 0. So this is a point at the origin. So we're going to hold on to that for a second and make sure it'll satisfy here. So here we have r equals 6 cosine theta plus 4 sine theta. So now we want to see if r equals 0 satisfies this. So if r equals 0, it is a point at the origin. You plug in r, you'll get the point 0, 0. So then this it's in here. So here is your polar equation for the rectangular form up here. Okay? So let's look at 2 more examples. We have r equals 4 cosine theta, and we want to convert it to rectangular form. So with this, we know from before that we can use these right here. We know r squared equals x squared plus y squared. So we're going to bring over, I have r minus 4 cosine theta equals 0. So I know what r squared is, but I don't see an r squared in here, so I can multiply both sides times r. I'm allowed to do the same thing to both sides. So now I have r squared minus 4r cosine theta equals 0. So now with this r squared, I have x squared plus y squared minus 4 r cosine theta, remember, was x, equals 0. So now I have x squared minus 4x, and I can complete the square, plus 4 plus y squared equals 4. So I'm completing the square. I added 4 to both sides so that I can get a perfect square over here, because I took half the middle term, which is -2, and I squared it. So now that I created this, I know this is x minus 2 squared plus y squared equals 4, which is the equation of a circle. And its center is at 2, 0, and its radius is 2. Alright, so we converted this polar equation to rectangular form, and a lot of times you'll see that the rectangular form, when converted to polar, is in fact a circle. So now this last one, we have r equals 4 secant theta. So we want to convert this to regular form, to rectangular form. So I'm going to multiply both sides. I have r equals 4 times 1 over cosine of theta. So I can multiply both sides by cosine. So I have r cosine theta. This cancels out, so I have 4. And then r cosine theta is x equals 4. So you have a vertical line. Okay? So it's important to remember some of those trig identities, even though I know you're not so fond of them. But these simple trig identities can get you to the next point. So all I did was multiply both sides by cosine theta to get something that I was looking for, because I knew I wanted an r cosine theta or an r sine theta in order to solve. So I was going from polar form to rectangular form. So just these few things are going to become very, very useful in converting, and make sure you remember these. And that is it for this lesson.